6.3. Proving that a quadrilateral is a parallelogram. So number 1, for what value of y must LM and P be a parallelogram? So y and 78 are consecutive angles, so that means they add up to 180, so subtract 180 from 78. Doing so gives you 102. And that's number 1. Number 2, for what value of x must ABCD be a parallelogram? So let's take a closer look at it. So diagonals bisect each other. That means this piece is equal to this piece, so we can set those expressions equal to each other. So we subtract 4x to the other side, we get negative x equals negative 2. Divide both sides by negative 1, and we get x equals 2. So let's type that in. So x equals 2 for number 2. Number 4, can the following quadrilateral be proven to be a parallelogram based on the given information? We can say yes, it is a parallelogram because both pairs of opposite angles are congruent. And that's number 4. Going to number 6. Quadrilaterals are formed on the side of a fishing tackle box by the adjustable shelves and connecting pieces. Explain why the shelves are always parallel to each other, no matter what their position is. In order to explain why the shelves are always parallel to each other, no matter what their position is, start by identifying any given information. So, looking at the picture, we're given that AD is congruent to BC, and AB is congruent to CD. Do the side lengths of ABCD change as the tackle box opens and closes? No, it does not. When is a quadrilateral also a parallelogram? If both pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So A. So since the quadrilateral is a parallelogram, what follows? Select all that apply. That means AD and BC are parallel, and AB and CD are also parallel, because opposite sides are parallel to each other in a parallelogram. Therefore, the shelves are always parallel to each other. And that's number 6. Number 7, complete the following 2-column proof. We're given that A and C are congruent to each other, and B and D are congruent to each other. And we need to prove that A, B, C, and D is a parallelogram. So the first statement says all 4 angles add up to 360, and that is because the sum of the measures of the angles of a quadrilateral is 360 degrees. From there, going from statement 1 to 2, they combine like terms and then factored out a 2. They're able to do that from the distributive property. It's the reverse of the distributive property. Going from 2 to 3, they divided 2 on both sides, so that's the division property. Now in statement 4, we're told angles A and B are supplementary, and angles A and D are supplementary. So for 5, AD is parallel to BC, and AB is parallel to CD, opposite sides. Now, if same side interior angles are supplementary, then the lines are parallel, which we saw from 4 that they are supplementary. So now ABCD is a parallelogram because this is the definition of a parallelogram. And that's number 7.